focuses in a lot on the key skills that are things that we kind of need and are focused on our linear functions mainly. But it's things that most of which you've seen before. For example, systems of equations. You have seen system of equations before. I know for a fact you have. I know for a fact you've seen them numerous times. Because systems of equations first gets talked about in 8th grade, and then it comes back in 9th grade, and we do some of it in geometry back in 10th grade. Assuming you're in 11th grade, that is. So, systems of equations are when you have multiple equations that are using the same variables, and we are assuming that those two equations are working together, that the x in one matches the x in the other, the y in one matches the y in the other, or if it's different variables, the key thing is they match. And we could solve systems of equations a few different ways. One way is graphing. Now, note I said we do not need the graphing calculator, because when it comes to graphing these, we're going to be graphing them by hand. So I'm going to give you the system of equations. Y equals 1/4 x minus 1, and y equals negative x plus 2. Negative. Wait, negative 1 plus x, what? Negative 1/4 x, yes. Sorry. I heard negative 1 plus x, and I'm like, where's the negative 1 plus x? I'm deaf and apparently blind because I missed the negative. Okay. So, I want to graph these. Thankfully, they are in the form of y equals mx plus b. Y equals mx plus b equations solve in a way that's pretty straightforward. They graph in a way that's pretty straightforward. Now I need an xy axis. I need some space to graph. I need to get a scale on my graph. At the same time. Now, as I do this, when it comes to graphing, if you do not put numbers along your x and your y axis telling me what these numbers count by, I'm going to assume they count by 1. If you're counting by 2s or counting by 3s or counting by 548, I don't care what you count by. If you're counting by something different, make sure to label the numbers along your axes. Now, to know if you need to count differently, you need to be able to look at your equation and ask yourself, what is the y-intercept and what is the slope? What is the y-intercept of my first equation? Negative 1. Remember, y equals mx plus b means these numbers are the y-intercepts. Okay, so I need to be able to get on my y-axis to -1 and to +2 somewhere. On my y-axis, are both -1 and 2 on the graph if I count by ones? Yeah, so we're good there. And then I need to be able to move with the slope. Slope is rise over run. So, if I'm talking about moving with the slope, from my y-intercept, I need to be able to move 1 and 4 from the point -1, which, by the way, right here, that's my first one's y-intercept, and I'm going to put a point there. Can I move away from it in any direction, either 1 or 4? Or will I run out of graph? I'm good. Okay, now, the slope is technically negative 1/4. If it's rise over run, the top is rise. Do I put that negative on the top, on the bottom, or on both parts of the fraction? I heard both. Is it both? Negative 1/4. So you're saying I put negative 1 and negative 4? But question, what is negative divided by a negative?
Positive.
Positive. If you put a negative on both top and bottom, you would just have a positive. If a negative was just a positive, do you think we'd use a negative symbol ever?
No.
No, you do not put the negative on both top and bottom. This is not true. Negative 1/4 is either negative 1 over 4 or it is 1 over negative 4. You put it on top or bottom, not both. Generally, we put it on top. So, that means I've got a negative 1. Rise. What directions can you rise?
Up or down.
Either up or down. So, since I'm putting the negative up here, I'm going to go down 1 and then 4 to the right or to the left. If it's positive, you go to the right and the 4 is positive. So from this point, down 1, right 4. I recommend making it for at least 3 points on your graph. Can I go down 1, right 4 again? No, but can I do the opposite? Can I go up 1, left 4?
Yes.
From this one, up 1, left 4. I recommend at least 3 points to help with the accuracy of your graph. Because these ones, the accuracy of the graph is going to make a difference. That's my first equation. I also need to graph the second one. What was the second one's y-intercept? 2. So on the y-axis, plot a point at 2. What's the second one's slope? Not negative x, negative, what number's here?
1.
Negative 1. If it's not a fraction, how do I do it as a rise and a run?
1 over 1.
I put it over 1, negative 1 over 1. Negative 1's down 1, positive 1 is right 1. I technically do as many of those dots as necessary to reach the other graph. The solution to a system is a coordinate point. It's the one coordinate point where the graphs that the two graphs have in common. In this case, this is our answer. What is that coordinate point?
Or negative 2.
It's to the right 4, and it's down 2 from 0, 0. Remember, coordinate points, left and right first, up and down second. It's opposite of slope. 4, negative 2. That is my solution. We're going to do one more by graphing, and then we're going to switch it up. X plus y equals 5, x equals 2y minus 4. Earlier, I mentioned about the first problem that those were pretty straightforward to graph because they were in the form of y equals mx plus b. Are these ones? No, but can I get them in the form of y equals mx plus b? In other words, can I get y alone? Yes. On the first one, how do I get y by itself? I wouldn't subtract the y and subtract the 5 because then you're also going to have to divide. There's a simpler way. Subtract the x. y equals, now you can either write it as 5 minus x, or more traditionally, y equals
Negative x plus 5.
negative x plus 5. Make sure you leave that negative on the x after you've subtracted it. Okay? I want to get the y alone on the second equation as well. Where do I start? Here's the y. The 2 and the 4 have to go. Which one goes first?
The 4.
To get y alone, when you've got something like y equals 2x minus 4, it's kind of like you're trying to get y alone when you have something like 5 equals 2x minus 4. Oh, I put my x and my y in the wrong spot, didn't I? There we go, that makes a little more sense. Imagine the variable you're not trying to get alone is just a number. How do I get y alone? How do I solve for y? I start by adding 4. And then I'm going to divide by 2. The only difference in a problem like this is when I add 4 to both sides, is x plus 4 going to combine? No. I get x plus 4 equals 2y. Now to get y alone, I divide by the 2. If you divide one thing, you divide everything specifically. What number hides in front of this x? 1. So, that becomes 1/2 x plus 4 divided by 2 is 2 equals y. And I graph them. I start with this one. What's its y-intercept? The y-intercept part of it is just the constant. Which part's the constant? Which part doesn't have the letter? 5. Y-axis, 1, 2, 3, 4, 5. Slope is the number in front of x. That's my slope, that negative right there, or more accurately, negative 1. To write negative 1 as a fraction, I put it over 1. Rise negative 1, run 1. In other words, down 1, right 1. What's the y-intercept on this equation? 2. On the y-axis, I go to positive 2. It's right there. My slope is 1/2. It's positive, so I'm going up and right. Up 1, right 2. My solution is where they intersect. They intersect right there. Coordinate points. Left and right first, up and down second. I went to the right 2 to get to that coordinate point, and I went up 3. Is right positive or negative? positive 2. Is up positive or negative? Positive 3. Graphing to solve a system of equations. It's not terrible. But it's kind of tedious, isn't it? Just to find one coordinate point. More commonly, you're better off solving algebraically. Especially since solving by graphing isn't great if your answers are decimals. Because it doesn't understand how to give you decimals. So more commonly, we're going to solve algebraically. There's multiple ways to solve algebraically. Today we're just talking about one of the ways to solve algebraically. Now, since this is a system of equations, we are assuming that this y and this y are the same thing. And this x and this x are the same thing. If they are the same thing in math, things that are the same can be replaced by one another. So, one option for solving a system of equations, it's called substitution. First thing you need is one of the variables, doesn't matter which one, but one of the variables completely alone in one of the equations. Do you notice y is completely alone on the first equation? Which means y can be replaced with 2x plus 4. These are the same thing. So, I can take my second equation and instead write it as 2x plus, instead of y, I can write what y was equal to. This gets you an equation that only has one variable. Are the parentheses actually doing anything here? No. If they're doing something, if they're protecting a multiply, do the multiply. If they're not, just get rid of the parentheses. Now I solve for x. Start by combining like terms. 2x plus 2x, 4x. Subtract 4. 4x equals 4, divide by 4, and x is 1. And we're not quite done yet, because the solution to a system of equations is a coordinate point. Coordinate points have two numbers, x and y. I have x. I need y. How can we find y? Plug it back in. I don't care which equation you're plugging it back into. I'll tell you, the one where y is alone is going to be easier. Two times 1 plus 4? 6. And coordinate points go x, then y. Does this look familiar? You've done it a number of times before. First thing you need to substitute is one of the variables 100% by itself. if we don't have it. That just means we need to manipulate one of the equations to get a variable 100% by itself. Is there one variable in this problem that it seems pretty easy to get alone?
Yeah.
Which one?
X.
X on the first one or the second one?
First one.
First one. How do I get that X alone?
Add 3y.
Add 3y to both sides. I will get that X is equal to 4 plus 3y. Once I have that, what that is equal to will go into the other equation. Just make sure you put it in the right spot. Am I putting it in y or am I putting it in x? X, because that's what it's equal to. Four y minus 3. It does not replace the 3. The 3 is still there. When you plug it in, you put parentheses. Are the parentheses doing anything here? Yes, they're holding on to the multiply. So make sure you distribute. 4y minus 12 minus 9y equals 18. Do y'all know how to solve for y from there? Dot, 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 you would solve for y, and I will tell you y will be equal to negative 6. Am I done? What else do I need? X. You can plug it back into either original or the version where X is alone. X is alone version is going to be the easiest one. You will get that X is negative 14. Make sure you write your solution as a coordinate point. What number is going to go first? Negative 14. X and then y. Every time. Now one more quick mention when it comes to your systems. Sometimes when you're doing systems, you'll go through the process and you'll get something like 5 equals 12. You'll go through all the math and you'll end up with something like 5 equals 12. Is 5 ever equal to 12?
No.
Do you know what that means our answer is?
There isn't 5 over 12.
There isn't one. There's no solution. You get a number equal to a number and those numbers are different, it's no solution. Sometimes you might get 5 equals 5. Is 5 equal to 5? Yes, it's always true. Infinite solutions. The solution is not infinity, but there are infinite solutions that would work. So, you can get no solution, you can get infinite solutions to pop up on these problems. And worksheet for y'all today. We're also going to cross some problems off on this worksheet. But I'm going to hand them all out before I tell you which ones to cross off. Cross off questions 3 and 4.